Hello everybody and welcome back again to another day of Math 7. So yesterday we talked a bit about theoretical probability, which is what we expect to happen based on doing the math with the information that we're given. So today we're jumping into some experimental versus theoretical probability and how they differ a little bit and what happens when we take a big number of trials in our experimental probability. So what is experimental probability? So remember, theoretical probability was what we expect to happen, what we think will happen by running the numbers. Experimental probability is the probability based on experimental experimental data or observations. So, an easy way to put this, theoretical, like I have said, what we expect to happen, where experimental is what actually happens when we do an experiment and collect data from it. So, our first example here, so we have 4 blue poker chips and 2 red poker chips are placed in a bag, which I happen to have here. So, if one chip is drawn out of the bag, what is the probability of drawing a blue chip? Well, there's 4 blues and 2 reds, so how many do we have altogether? Well, we've got 6 in that bag. And how many of them are blue? Well, we've got 4 blue chips. So that's going to give us a probability of 2/3. Now let's check it out for the red. So we've got 6 total chips, that hasn't changed, and we have got 2 reds in there. And then we get 1/3. And this should make sense because if we draw a poker chip, we have a 100% chance of drawing a poker chip. So the 2/3 of the blue and the 1/3 of the red gives us our 100% there. We're going to draw a chip no matter what. So is this theoretical or experimental? Think about it for a second. And if you guessed theoretical, you are correct because we ran the numbers. We haven't done any experiment. We've just seen what we can expect to happen. So now we're going to conduct an experiment with this handy-dandy bag of poker chips that I have. So I know you guys don't have them, so you'll just follow along with me. So I'm going to reach in and draw a random chip. And the first one that I got is blue. So we're going to put a tally on blue. And then I'll throw that back in the bag. Give it a nice little shake-up mix and draw another one. Ooh, this time I got a red chip. So we're going to tally for red. So we're going to start out with just doing around 10 draws real quick to see what happens. Alrighty, random, here we go. Alright, this time I got a blue chip. Put it back in the bag. Give it a nice mix. Sorry about the noise, my microphone is right next to the bag of chips here, so. Alright, and we get a red chip. So there's 4. Randomly pick a chip. Ooh, we got a red. 5 tries. A blue chip. A blue chip. We got another blue chip. I should be crossing for 5s, so whoop. 1, 2, 3, 4, 5. Back in the bag. A blue chip. Alright, so we got one more draw here. Let's see what happens. Actually, yeah. And a red. All right. So how many total trials did we do? Well, we did 10. So we're going to make our experimental probability. We're going to make a fraction and put how many trials we did on the bottom. So experimental probability of blue, well, we did 10 trials and we got 6 blue chips. So that is going to be a 60%. And then we got 4 out of 10 trials, so 40%. All right, so how does the theoretical probability compare to the experimental probability? Well, we said 2/3, so 3/5, pretty close to 2/3, but you know, when we're dealing with only between 0 and 1, we're still a little bit far away. And so we can say kind of close, but not quite equal. All right, so we're going to continue our experiment here. So I'm going to keep using the table up above. We're going to do 10 more draws here. And I got a blue chip, so we're going to continue on with blue. And another blue chip. Got a red chip. And a red chip. A blue chip. And a blue chip. Another blue. Another blue. All right, so we got 2 more draws to do, it looks like. I've got a red and nice mix up here. I've got a red. All right, so now how many total trials have we done? Well, we did 20. So we're going to check out the experimental probability of the blue. So we did 20 trials this time, and I got, looks like 10/12 over 20. Which happens to be, I don't know how this happened, but remember probability is random. 6 over 10 or 3 over 5, which is still 60%. Interesting. So that doesn't happen very often. We got the same experimental probability when we did more rounds of our experiment, which means we got 8 out of 20 for our red chips, which would still give us a 40%. Now, how do they compare? Well, we can see that they are the same as they were. So this is really rare. What we were trying to see happen was, excuse me, oh, sorry about that. So what we were trying to see is when the number of trials in the experiment are increased, the experimental probability starts to mimic our theoretical probability, or the experimental probability number will get closer to our theoretical probability. And this is what we call the law of large numbers. And the law of large numbers says that when we do more experiments, when we do more trials of our experiment, what we get when we actually do it gets closer and closer and closer to the theoretical probability. So if I were to keep doing this experiment, my blue chips would get closer to 2/3, and my red chips would get closer to 1/3. So we have a little bit of time here. I'm going to do 10 more draws just to see if we can start to see this happen. So we've got a blue. We got another blue, so that's 2. And another blue. Got a red. Got a blue. And this is completely random. I'm not looking in the bag, I'm just randomly picking. I'm seeing how this goes. I got a red. I got a red. I got a blue. So it looks like I need to do 5, 10, 15, 20, 25, 2 more draws. I got a blue. And finally, a blue. All right, so now we're going to compare these again to see if we get what the law of large numbers says. So I did 30 trials this time. And I got 5, 10, 15, 19 out of 30. Which, if I turn that into a percent, let me get my calculator out real quick. So we said 19 divided by 30 is 0.63333. We'll just call that 63%. And our theoretical probability for that was 66%. So we can see that we're starting to get a little bit closer there. And then here, for my red chips, I had 11 out of 30, which is going to give us 37%. Which the red chips theoretical probability says that it should be 33. So we can see how we're starting to inch our way a little bit closer to our theoretical probability. So that's the law of large numbers in action. We're starting to see it happen. We're not going to get there right away, but as we keep doing more and more and more trials, those numbers will start to shift to where they should be. So this guy will get closer and closer and closer to 67%, like the theoretical probability says it should be, and this guy will get closer and closer and closer to 33%, like the theoretical probability says it should be. So that's how we do experiments to find probabilities. We enact the thing that it described. So if we were talking about rolling a dice, then you would take a dice and roll it and record the number that you roll and see. Let's say you wanted to roll a 4, which we know the probability should be 1/6. So you would roll and roll and roll and record all the things you get, and then divide how many times you got a 4 by the total number of times you did the experiment. and that will give you the probability for experiment, the experimental probability. All right, so pretty not too difficult here. We know the difference between theoretical and experimental probabilities now, and we know that if we do a bunch of our experiments, we will get closer and closer and closer to the theoretical probability, and that is what we call the law of large numbers down here. So keep that in mind as we go. All right, so we are going to start our independent practice now. So it starts on our notes page here, so just be aware of that, and be sure that you're including these first 5 problems on your assignment. The rest of the assignment will continue on the next page in your Canvas portal, so don't forget about that either. As always, if you have any questions or get stuck or just any observations you'd like to make to me, then feel free to send me an email or a message on Canvas, and I will reply to you as soon as I can. Thank you, and have a great day. Bye-bye.